All right, this is going to be AP Calculus Self-Check 3.3. So let's go over problem number 1. There are 5 problems, 10 minutes. You guys know the deal. All right, so the function f is given by this guy. So look at all of our multiple choice. Increasing and decreasing, that's all it's asking. All it's asking us to do is do f prime, because the definition of increasing is f prime is greater than 0. Definition of decreasing is f prime is less than 0. So let's find f prime. Do that for me, girls. F prime is equal to, shout it out.
3x squared minus 12.
Minus 12. And then minus 0, right? So now I need to find where this thing is increasing and decreasing. So again, I need to do what? Find the critical values. Critical values are where?
0 or d.
For f prime, exactly. So when I do this, I factor out a 3 times x squared minus 4 is equal to 0. 0 product property says 3 equals 0, which doesn't happen, or x squared minus 4 equals 0. So x squared minus 4 is equal to 0 is the only one I really need to solve for. That means x squared is equal to 4. Square root both sides. X is equal to plus or minus 2. So then I come
That's
up.
where I got it.
Oh, and then I remember you were like, it should be square root. And like I thought, I like totally like went with it. Like I was like, oh yeah, like that makes sense.
So then I make my number line at -2 and 2. I'm plugging in values into here. So let's plug in -3. Let's plug in 0. Let's plug in 3. When I plug in -3 into my derivative, I like plugging in right here. If I plug in -3, I get a 9. 9 minus 4 is positive, so that's going to be a positive. Therefore, this is increasing. When I plug in the 0, 0 minus 4 is a negative. That's a negative. That's decreasing. And when I plug in the 3 again, it's 9 minus 4, which is a positive. That is increasing. All right, so the correct answer here is A. It's increasing for x is less than 2. It's decreasing between -2 and 2, and it's increasing for x is greater than 2. Thumbs up, thumbs down. Did you get this one? Hey, nice. All right. Number 2. Oh, wait. Are there questions before I move on? All right. Number 2. The derivative is this. It already gives us. How many points will it have a relative maximum? All right. So it's already given us the derivative. What is the definition of relative maximum?
When f prime has a sign change.
Not exactly.
Goes from
Positive to negative.
Yeah, positive to negative. So this is positive to negative for f prime. F prime goes from positive to negative. All right, so we have a point at -3, a critical value at 0, and a critical value at 2. These are all CVs. CV, CV, CV. You guys saw how I got that?
Oh, because x to the 4th equals 0.
Yep. Each of these 3 things is set equal to 0. I solve for x. All right, so now in between here, I guess I should have stayed with blue, but I'm going to switch back to blue. I'm going to plug in -4. I'll plug in -1. I'll plug in 1. I'll plug in 3. So when I plug in -4 into this thing, I see that I get a negative. I don't have to worry about this thing. This thing is always positive, right? So I'm only worried about these 2 things. So a -4 and a -4, that's going to be a negative. That's going to be a positive. We see this?
Yeah, I got it.
Increasing. Cool. A -1, that's going to be a negative, and a positive, that's going to be a negative. A 1, that's going to be a negative and another positive, so that's going to be a negative again. And look here, this is a shortcut. Whenever I have anything to an even power, x to the power 4, I jump over it without changing signs. I jumped over this 0 without changing signs. It's a negative to a negative. That is the shortcut if you want to try to memorize that. Anything to an even power, it doesn't change the value. It doesn't go from a negative to a positive or from a positive to a negative. X to the 3rd, then it will. Yeah, so you can't have a relative extremum. You can't have a relative extrema at an even power. And then this one is not an even power. It's to the first power, so I know it's going to switch again. That's a quicker way. All right, so all of this is decreasing, decreasing, increasing. All right, so I need to figure out where the relative maximum is. Maximum is from positive to a negative. There's only one of them. It's that one. That's a max. That was nothing. This one was a minimum. So there's only one max. Correct answer is B.
Even though I forgot one CV, it's
Nice. Thumbs up, thumbs down. I didn't even see everyone. Everyone got thumbs up? Wow, okay. Joy, what did you get? Thumbs up, thumbs down?
What are you trying to say?
Okay, darn. All right, number 3. The graph of this is concave down. What does that mean we have to do with the graph of y?
You have to solve for the derivative twice.
Yeah, the double derivative. Double derivative.
So hard.
Yeah, but I was not getting it. Like,
I did.
So let's do it together then. Y prime is, shout it out.
Oh,
X
no, I am
cubed
a
12x
I
cubed
didn't solve for the double derivative.
minus 48, what?
Caleb.
Q or
Uh,
square.
Just add.
Plus
Oh wait. Yeah, that is correct.
48x.
48x.
And then
Wait,
finally,
48x.
From the 24x.
that's powerhouse.
Oh,
Yeah.
Got it, bro?
Y double prime is going to be what?
36x squared.
One day this year, can we just all dress like guys?
Yeah.
Yeah.
No, let's do it.
Just randomly.
Plus 48.
Perfect. Now we need to set that equal to 0, right?
Yeah, I know.
So I'm going to go ahead and do a few things when I set this equal to 0.
this is where I got stuck.
So I'm going to factor out a 12. Each of these is divisible by 12, so I'm going to say 12 times something, and I'm going to set that equal to 0. So if I factor out a 12, what times 12 is 36x squared?
3,
3x squared. What times 12 is a negative 96x?
8,
Negative 8x. And what times 12 is 48?
4.
Perfect. Then I need to factor this guy, and hopefully we remember how to factor. This is going to be 3x
So
minus
you
2,
think we can do these problems within an hour
x minus 2. Do them.
plus our test?
Yeah. Do you think you can?
No.
Oh.
They take me so long.
yeah, like,
Okay, that
Like,
just
I-
means you have
I
to go
got-
over
this
them.
whole time, I barely got to number 3.
Oh, okay.
yeah.
That just means we need to study more and more and more until it gets faster and faster and faster. But that's good that you're getting them. It seems like you got the last two
Well,
questions.
like,
So.
I feel like I get the concept, but it's like when it's the numbers, it takes me so long.
Yeah, like these huge numbers are killing me. Smalls.
Yeah,
Right.
that's what
Especially when I
freaked
have a
me out because
calculator.
if this were easier, I think I would have got it. But it's just like, oh my god, like algebra.
All right. Was everyone able to factor this guy?
No.
No.
I didn't even.
Wait,
I just got to
tried,
the
but
30x,
I didn't even do the double
36x
derivative.
Yeah, I
squared
tried
minus.
No,
Should I talk about how to factor him? Do we remember our rules?
Yeah, let's factor.
Yeah.
Let's factor. Okay, so do you guys remember diamond problems?
Yeah.
Okay, with advanced diamond problems, I multiply 3 and the 4 and I put it on the top. So this is going to be 12.
Oh, I forgot about that part.
3 and
I
4.
put 4 on the top.
Yeah,
And I
the-
couldn't figure it out. I was like, nothing goes into 8 that also goes into, like, you know?
Yeah, exactly. So you multiply 4 and 3, put it on the top, and then I go ahead and say what adds up to negative 8 but multiplies to 12? Adds 8. Adds.
What?
So what adds to negative 8 but multiplies to 12?
Negative 6 and negative 2.
There it is, negative 6 and negative 2. And then I need to put these both over the numerator. Both over, or not the numerator, but the first term. So both over 3, both over 3. So this is saying 3x minus 2, or, and I have to reduce fractions here too. So this is going to say, this says 3x minus 2. So this whole thing, the way that I read that is 3x minus 2. And I reduce the fraction over here. This is going to be a negative 2 over 1, which, and then you always put the x on the denominator. So this is going to say a 1x minus 2. Those are the two factors.
I'm so confused.
I'll go over this a little bit slower. So again, I multiply the 3 and the 4 to put in the top of my diamond problem. I take the coefficient of the middle term, put it in the denominator, and I ask this question, what adds up to negative 8 and multiplies to 12? And the answer is negative 2 and negative 6. And then I divide them both by this first term's coefficient. Divide both of them by 3. And I can't divide this one by 3, can't divide this one by 3. Simplify both fractions. That one's simplified. I simplified this one. Leave x in the denominator. And it's going to be 3x minus 2. You use the denominator with x minus the numerator. And then 1x minus 2. That's how I get both of the factors. Now that I've factorized it, I need to, or factored it, I don't know where that word came from. I factored my equation. I need to solve for x. My two x's are what and what?
Positive 2.
Positive 2 and
Negative 2 over 3.
close, positive 2 over 3. Because when I add the 2 over, it's going to become a positive. Divide both sides by 3. All right, now that I have those, I can start subbing in things. I'm going to sub in a 1, a 0, and a 3. If I sub in a 0 into this form, this is probably the best form to take the derivative in, where it's factored. If I plug in 0, this thing is always going to be a positive 12. Don't worry about him. Let's worry about the rest of him. The rest of these two factored terms. If I plug in a 0, that's going to be a negative 2 and a negative 2. That's going to be a positive. If I plug in a 1, that's going to be a positive 3 minus 2, so that's going to be a positive, and a negative, that's going to be a negative. And when I plug in a 3, that's going to be a positive and a positive, which is a positive. So this is increasing. Or sorry, this is double derivative. It's not increasing. This is where it's concave up and down. So this is up, this is down, and this is up again. So it's asking, where is it concave down? It's concave down between 2/3 and 2. Between 2/3 and 2.
Wait, what was it asking for? Down?
Concave down, yeah.
Yeah. So it's less. It's E. Oh, you already circled.
Yep.
It. I was like, why are you waiting?
So up, down, up.
All right. Pausing here. I see pencils writing. All right. Rosalie's still writing.
You can go.
All right. Going on to problem number 3 out of 5, or problem 4 out of 5. All right. If f is defined by this function, what are all the x coordinates of the points of inflection? Inflection means I'm finding what? F prime or f double prime? F double prime for inflection. Yeah. So here we go. Let's find f prime first. F prime is equal to, shout it out,
5x raised to the power of 6.
Ah, there's a bug on my leg. Oh, good.
plus,
24 x raised to the power of 5.
yep,
30x raised to the power of 4.
yep,
And then 1.
plus 1. Perfect.
Wait, what happens to the over 7?
So 7 gets multiplied by down, and then 7 and 7 cancel each other out. Powerhouse just comes down.
Well, that would have made my life easier if I remembered.
Pausing here for about 5 seconds.
Wait, pause more.
Pause more. Pause for 15 seconds.
If only there wasn't that 1 there, you could factor out like a whole bunch of
Okay.
And now that we're taking the double derivative, the 1 will go away, Kaylin. So, taking the derivative, someone aside from Joy do this? I think Joy knows how to do it.
You have 30x squared.
Close.
To the power of 5.
To, oh yeah, to the power of 5.
Plus
120.
120 x to the power of 4. Plus
120 again.
Wait, I got 125 for the first one.
for the 5 times 6.
No, not the first one. The next one.
24 times 5. So this is seen as, here I'll show you the trick. 20 plus 4 times 5. 5 times 20 is 100. 5 times 4 is,
20.
Oh, wow.
yep,
Bam!
That's a cool.
distributive property.
Look how like my arms can reach like
All right, so
Kinda like you're reaching
moving on. In order to find a possible point of inflection, what do I need to do? It's kind of like the critical value for the f prime test, but it's a little bit different for the f double prime test.
0?
Yeah, set it equal to 0. So I'm going to
Can
say,
we take out like
I'm such a
3
pro.
and x cubed?
I'm going to do it all at the same time. I'm going to take out a 30x cubed, and I'm going to set it equal to 0.
Oh my god.
And I'm going to set it equal to 0. Okay, if I factor out the 30x cubed, what's left in here?
Couldn't you already look at that? And if you're setting it to 0, you'd know x equals 0?
You have to be careful here because you have to factor it all out because you need to figure out what's left in here.
Careful here.
Because you have to find all of the factors.
46.
Plus
I got this wrong, I can't
4x, yep,
And then 40.
plus 4. Yeah, that extra 0. Yeah, good job. And this guy, it needs to be factored more. So 30x cubed times these two things. So there's a total of 3 factors. I guess I can leave that in parentheses here. What times what gives you x squared plus 4x plus 4?
X plus 1,
Close.
2.
It's x plus 2 times,
X plus 2.
yeah, there it is, equals
I
0.
am literally so dumb. Like I was like, I can't factor x squared plus 4x plus 4. Like what's going on? And like I was like trying to find the mistake. And like you can't factor it. Like I'm so.
See, I feel like we need to do a factoring lesson.
Yeah, I
because
know.
that keeps screwing.
Like it always gets it.
All right, so from here, we know that we have a critical value at, ooh, look at this one. This can be turned into, ooh, look at this. Ready? This thing, get rid of that, and then this can be turned into squared. Anything with an even exponent, we know it's going to happen.
Positive.
Yeah, so, well, it's not going to change signs. So I have a critical value here at -2, a critical value here at 0. All right, let's check a value. I'm feeling a -3. I can check a -1.
Do you have to check it, or is it
You
just
actually-
asking for the inflection points?
Inflection point, what is the definition of inflection point?
Where F prime
Equals 0.
changes sign.
Changes sign.
Aw.
So IP is
So
for F.
confused. When does it equal 0?
F, for the double derivative, you never set it equal to 0, but you do if you're trying to find the inflection point, but that's not the definition. A possible inflection point is where F double prime is equal to 0.
Oh, okay.
Alright, so when I plug in -3 into this factored form, again, factored form is the nicest thing to sub into. -3, that's going to be, is this a negative or a positive?
Negative.
That's a negative. A -3 here is going to be,
Positive.
doesn't matter because it's always going to be
So it's
positive.
you're always gonna.
So negative.
Son of a.
Every single one.
So that's a negative. And then this one right here is going to be negative because it doesn't change signs over the -2. The -2 was, we got that from this factored form. It's not going to change signs when it's to an even power, but it is going to change signs over here because this is to an odd power, to the power of 3. All right, so points of inflection are where I change signs. There's only one inflection point. It's right here.
So 0 only.
0
I
only.
got that one wrong, right, but like through the wrong way.
All right, thumbs up, thumbs down. It's okay if we got thumbs down. I just want to know what we got.
Oh, I never got to it.
Okay.
Wrong way.
I just literally made a mistake on factor.
And last but not, oh sorry, yeah.
Why is it negative in between -2?
Wait, so why is it 0 only?
Why is this one negative here?
Yeah.
So there's two reasons. The first reason is because we got -2, the possible inflection point, from this factored form. This factored form is to the power of an even. Even powers don't change signs, so that's the easiest way. The second way is if I plugged it in, this one would always be positive, and then this one is going to be negative again, because I'm plugging in a negative value. Okay, perfect. All right, question before we move on to number 5.
I think I'm good.
All right, last question before we move on to the self-check 3.4. So if f of x is equal to this, which of the following is true? Look at all the multiple choices, all increasing and decreasing. That means I'm doing what test?
F prime test.
F prime test. Taking f prime, this is going to be quotient rule. Quotient rule says
Oh,
close.
Low D high, high D low.
Low d high minus
High D low.
high d low all over low low. All right, so low is going to be x, d high is going to be 1 over x, minus high is going to be natural log of x, low is going to be, or sorry, d low is going to be 1. All of this is going to be divided by x squared.
Wait, so how do you know when to do this test?
Like any kind of fraction.
So you know quotient rule, when I have an x over an x, I know that I need to do f prime test because increasing and decreasing deals with f prime. I memorize the definition of increasing, that's when f prime is greater than 0, and decreasing is f prime, there it is, less than 0. All of these are dealing with f prime, therefore I need to find f prime. To find f prime, I know I have to use quotient rule, that's what we're doing here. All right, so simplifying this a little bit, we have 1 minus natural log of x all over x squared. All right, so I need to find critical values. That is where the bottom equals 0 or the top equals 0, right?
Yes.
All right, so top equals 0, x is equal to
1? Oh, fudge. Freaking E.
e, yeah. Because to get 1 here, so again, if I'm solving for the top, let me come down here and do this. If I'm solving for the top, I'm getting 1 is equal to natural log of x because I add natural log of x to both sides. How do I get natural log of x to equal 1? Well, natural log of e is 1.
So ln of e.
Yeah. And I guess the technical way that you do this is e to the power of 1 gives you e to the power of natural log of x. E and natural log, these guys cancel each other out. And you're just left with e to the 1 is equal to x. So e to the 1 is equal to x. All right, so now we have our two critical values. Let's go ahead and plug those in on our x-axis. So I come back over here.
Good. You think I have room for that?
So I have x equals 0, x equals e. Again, e is about 2.718, so 2.7. And those are my critical values, CVs, CVs. All right. So things to sub in, -1, I can sub in 1, I can sub in 3. So at -1, plugging into this form, at -1, uh-oh, I have natural log of a negative.
And you can't do that?
Can't do that. That's not in the domain of natural log. So don't worry about that.
Negatives with an natural log ever.
Ever. Unless you somehow have an absolute value to get rid of the negatives. Alright, what happens if I plug in something smaller than e? Something smaller than e, that's going to be, I don't know, like 0.5 or something less than 1. So 1 minus something less than 1 is going to be a positive. This is always going to be a positive on the bottom.
Positive.
So this is going to be a positive. Positive, therefore increasing. And now, when I say take natural log of something bigger than e, like natural log of 10, that's going to be slightly bigger than 1. 1 minus something bigger than 1 is going to be negative. This one is always positive on the bottom, so this is a negative, a
So
decrease.
how do you
Yeah.
know, like, you take L, like, how do you know for the ln?
So the way that I memorize ln is this. I have a graph of natural log where I know that this value here is 1, this value here is 0. I know this x value is 1. I know this x value where I match up with 1 is e. You memorize this graph, you're ready for natural log. And you also have this graph to tell you that you only have the domain of positive values. You never have anything over here. You're not allowed to have anything over here.
Wait, so then how did you get D and E for the first part?
So if I'm plugging in a negative value, it's
Oh.
not on the graph.
Okay.
So it does not exist over here.
Is it me?
All right. So let's choose our answer. I think it's here. Oops. Yeah. So f is decreasing for all x greater than e, all x. Let's go through these. F is increasing for x greater than 0. No, because it's decreasing after e. F is increasing for all x greater than 1. No, not the case. F is decreasing for all x between 0 and 1. It's increasing for all x between 0 and 1. F is decreasing for all x between 1 and e. Between 1 and e, I mean, it is... Oh, it's increasing there, so that's not even true either. Perfect, so process of elimination, E. All right, questions on any of these 5 questions before we move on to self-check 3.4?
No, we don't have.
All right, that concludes the video. Say goodbye.